Good morning, class. Welcome back to AET 3830 IoT and Industrial Applications. In the last unit, we talked about the considerations and constraints of implementing IoT solutions in the real world. So let's think about this. So when the engineers are trying to build a new building, what they will, and also when the designers are designing a new design for a car or for a bicycle, for example. So usually they don't start from scratch, right? They may have some previous references. They may have some blueprint. Basically, they will begin with some best practices in that field to start with. So for this unit, we'll talk about the best practice in IoT solutions. Basically, we'll talk about the architecture and the reference model. The content for this unit is straightforward. So we have an introduction of these two concepts. So the reference model and the reference architecture. Then we will, based on the current standard, we'll give you some taste about these two concepts. Basically, how they are used to guide different IoT solutions. So basically, later on, if you go to work or if you work on projects, basically this reference model and reference architecture are one of the first things you will start with and looking into before you move into the specific design. So this unit corresponds to chapter 7 and chapter 8 of the textbook, mainly chapter number 8. For this chapter, you may have noticed that the PowerPoint is quite long, but actually, I would say maybe 40% of the content is for self-reading. Basically, those content will provide you more information about some concepts to help you understand those concepts, but they will not be covered in detail in the lectures. So what you will focus on is the first two categories here. So the fonts, the common fonts, and the fonts in the red color. And for the fonts in italic, so they may come in different sizes. So those are supporting reading materials. So as I mentioned in the beginning of this course actually, so you can learn this course quite well without the textbook. But by doing so, I need to include much supporting materials in the PowerPoint. So for those materials, I may not be able to cover them into detail in the class, but it will be very beneficial for you to read them after we cover the first two categories of information in the class. So don't be scared by the large number of PowerPoint in this chapter. So basically 40% of them are for self-reading and they are supportive material. Okay, with that in mind, let's have an introduction. Just now, for the examples I mentioned earlier, so basically we need some best practice, some guidance or some blueprint or some references to begin for an IoT solutions. Basically, we don't build from scratch. Most of the time, we may, develop based on previous successful implementations, successful solutions. So we may use them as a template or reference to start with. In that case, the best practice, the template, or the blueprint, as we may call in our context, it is an architectural reference model. So under this model, we have two items. So actually, it's the reference model and the reference architecture. So if you are a computer science guy, you may be familiar with these terms, but if you are not, it doesn't matter. You don't need to worry. So for this class, we focus on giving you some lower level knowledge in that area, but we don't need to go to the details. So for the reference model is a model that describes the main conceptual entities and how they are related to each other. For example, if it is for a vehicle, a reference model may include the engines, the lights, the wheels, and how they are associated with each other. For example, the wheels installed onto the chassis and the engine is put into the front of the car, maybe. Those reference model. And for the reference architecture, aims at describing the main functional components of a system, as well as how the system works, how the system is deployed and what information processed. Basically, it talks about the functional aspects of the system. So if it is still the car, then it will talk about how the engines are move, how the engines and the electricity generator are cooperating with each other, how the turning wheels are implemented, those kind of things. Basically, the reference model describes what are there and how they are associated with each other. And the reference architecture talks about how these components are working together. So for this course, we use an example from the IoT ARM. So because it is currently most complete model and reference architecture. So that's what we use here in this course. So based on our description just now, we can tell that the foundation of a reference architecture is the reference model, right? Because we need to first describe what are there, how they are related to each other, and then we can describe how they function together to accomplish the functions. Okay, so now let's go to the reference model. So a reference model describes the domain using a number of submodels. So for this class, we'll look into some of these submodels and help you get some ideas. So we have the IoT domain model, and then we have the IoT information model, IoT functional model, and IoT communication model. So because the communication is one of the functions of the IoT solutions, right? Yeah, we need to communicate. So IoT communication model actually is derived from the IoT functional model, but we will look into that more detail. This slide describes how the models are, why these submodels are needed in the reference model. Okay, so by the way, the submodel we mentioned here, 1, 2, 3, 4, they together form a reference model. In other words, a reference model includes such submodels. So those are the relationship. So the domain model of an architecture model captures the main concepts and entities. We look into this entity. For example, you can know that for IoT solutions, we have devices there, right? So that's one kind of entities. We'll look into other entities. And in that case, we also need the information model because we have many information, data inside the operations. And then the domain and the information model contains concept entities of its own, and they need to be described in a separate model, functional model. Basically, this is also providing the foundation for the reference architecture, because by the end of the day, the system needs to work, right? So as part of the functional model, we need the communication model because IoT emphasizes a lot on the communication. So that's an overview of the reference model. So the reference model includes 4 submodels. And the other part of the ARM architecture reference model is the reference architecture. It is a communication tool for different stakeholders of the system, and it involves the presentation of multi-phases of the systems. So in the second part of this lecture, we'll see how these multiple phases can be described. So we'll look into the functions, we'll look into the information, and so on. So for the high level, for the reference architecture, we need to introduce the concept of reference architecture. Basically, that's the general architecture. Okay, basically you can consider general guidelines, general template, general blueprint. And then based on that, and according to the specific applications, scenarios, requirements, we will generate the concrete architectures. Basically, we use a template, and then we generate specific architecture. Specific means that we may remove some of the components in the reference architecture. We may also modify some layout. We will also add some specific elements to reflect the real-life requirements. And based on the concrete architecture, so we will design, engineer, build, and test the actual systems. And the actual systems will provide feedback to the concrete architecture. And if many feedbacks are indicating the same issue, and then the essentials will be extracted and put back to the reference architecture, so that when we move into another solution, the updates will be reflected already in the reference architecture. So for example, if you are designing vehicles, maybe in a cold area, maybe in Norway, Finland, those kind of stuff. So for the reference, the actual system may give some feedback that, for example, the vehicle need to have some self-warming function, so that the vehicle is not frozen in those winters, right? So this will go to the concrete architecture of the vehicle, basically into the design guidelines, and this will also go to the essentials for the general template. Basically, for vehicles in the cold weather areas, they need to have the warming function. So that's how architecture evolving. So concrete architectures are instantiation of rather abstract and high-level reference architectures. So once again, for a vehicle, the reference architecture may indicate that a vehicle need to have a cabin, need to have 4 wheels, need to have an engine, something like that. But when we go to the detailed blueprint of a vehicle, so you know that we need to specify the size of the wheels, the power of the engine, those kind of stuff. These 2 paragraphs describe the relationship between the reference architecture and the concrete architecture. Basically, they can be summarized in this sentence, right? And sometimes the process is iterative. Basically, that's what we can see in the figure. So we use the reference architecture to generate concrete architecture and then go to the actual systems. And the actual systems will give feedback to the concrete architecture. And for the feedback essentials, it will go to the reference architecture for the future development. So that's why we consider them to be iterative. Okay, this figure shows the relation between the reference model and the architecture model. Basically, the reference model is here, and that guides the reference architecture. And these 2 things together is what we discuss in this chapter, architectural reference model. So in my opinion, it's just few words missing together. Anyway, so the figure shows 2 phases of IoT IRM. So how to actually create an IoT IRM and how to use it with respect to building actual systems. Okay, that's the first part of this lecture.